Also look at the number of different possible right turns, okay? So let's have a look. How many right turns have you made to get into bin 0? Good. So no rights. No rights. How many rights have you made to get to bin 1? How many? One right, yeah? How many different ways are there of getting to bin 2? How many rights have you made? Yeah, good, so 2 rights. How many different rights have you made to get into bin 3? Yeah, so you've had to make 3 rights in your 4 choices. How many rights have you had to choose from to get to bin 4? Okay, so all of the choices are right. Now, so that makes sense, okay? To bin 0, you've made no rights. To bin 1, you've had to make 1 right and all the rest are lefts, okay? To get to bin 2, you'd have to make 2 rights and then the others are lefts. To get to bin 3, you've had to make 3 rights and all the rest are lefts. And to bin 4, you've had to make all 4 choices to be rights, okay? Now, this kind of feels a bit binomial, doesn't it? Because if you say that a right is a success, okay? So x will be our random variable that represents the number of right turns. So in other words, that is our success. The number of right turns is our success. A right is a success and a left is a failure, okay? Then each time you're having to choose, you have to make 4 different possible choices to get into a bin. Yeah, because there's 1, 2, 3, 4 different rows. So you're going to have to end up at 4 different pegs and you're going to have to choose either left or right. Okay? If we say that a right is a success and a left is a failure, that kind of feels a bit binomial, doesn't it? Okay? So have a look. To get to bin 0, you're basically asking, what is the probability that x equals 0? In other words, if x is the number of right turns, what is the probability that you've made no rights? Does that make sense? Yeah? To get to bin 1, you've asked what is the probability that the number of right turns, x, is equal to 1. To get to bin 2, you've asked what is the probability that x equals 2 right turns. What's the probability that x equals 3 will be for bin 3, and what's the probability that x equals 4? In other words, all of those choices are rights for bin 4, okay? Now, do you notice, in fact, let me put my lefts in there as well. So this is 4 lefts, 3 lefts, 2 lefts, 1 left, and 0 lefts, okay? Do you recognize these kind of numbers here? So the 1, 4, 6, 4, 1. So the 1, 4, 6, 4, 1 is the number of different possible choices you have for each of the possible 0 rights, 1 right, 2 rights, 3 rights, and 4 rights, okay? So for example, if I'm saying here, I'm saying, well, what is the probability that x equals 2? I have to think about the number of different possible ways there are of getting 2 rights in all of these choices. Okay, 2 rights, 2 lefts. Does that make sense? Okay, let me explain that again then. So these numbers here, okay, you're happy that the ones in red, these ones here, are the number of right turns you've made to get into that bin. Okay, so each bin, it's consistent. So to get into this bin, you've had to make no right turns. To get to this bin, you've had to make 1 right turn. To get to this bin, you've had to make 2 right turns. This bin, you've made 3 right turns. And this bin, all the choices have been right, all 4 right turns. These just correspond to the number of different left turns you've made. So it's literally just a reciprocal. That goes up, that one goes down. Does that make sense? They're just complements of each other. Yeah? So these just 2 here just correspond to the number of right turns, the number of left turns that you've made to get into each bin. But these numbers here represent the number of different possible ways there are of getting into that bin. Does that make sense? That's literally what you did right at the very start. I just said, find me the number of different possible paths there are of getting into each bin. And you told me there was only 1 path to get to bin 0. There was only 4 paths to get to bin 1. There's only 6 possible paths to get to bin 2, 4 possible paths to get to bin 3, and 1 possible path that gets me into bin 4. Does that make sense? Yeah? Now, does anybody recognize these numbers? Not quite. Not quite. Can I just pick one of these? Good, absolutely. Now, just to emphasize that a little bit, so it's to do with the NCR notation. You remember our combinatorics notation? It is absolutely to do with that. Just to emphasize this a little bit more closely, let's just pick one. Let's just pick the probability that x equals 1, okay? So, if I want to find the probability that x equals 1, I guess first of all, I need to write my distribution. Now, in this case, my distribution is going to be binomial. You happy we've already said that? Okay, because we're looking at the number of right turns. So a right is a success and a left is a failure. Okay, so how many trials are we doing here? How many choices? Every time we drop a ball, how many choices does that ball have to make? 4, right? It's got a choice here, a choice here, a choice here, and a choice here. So it's got 4 rows, so therefore at each peg it's got a choice. Does it go left or does it go right? So you can think of this as 4 independent trials. That makes sense? So every time it picks a peg, goes left or right, that's a trial. Yeah? So there's 4 possible trials that it's making. What's the probability of its success? What's the probability that it's going to go right? A half, absolutely. Okay? So now I've got this, I should, in theory, be able to work out the probability that x equals 1. Just remind me, how do I work out that formula? Just give me the general formula. It is, but where does that 4 come from? Good. So it's NCR times by the probability of success to the power of r times by probability of failure to the power of the leftover bits, right? The leftover trials, okay? So in other words, the probability that x equals 1, we're making 4 choices and we want to know how many of those choices result in 1 success. In other words, a right turn, okay? We're going to multiply that by p. P, the probability of making a right turn is 0.5. Probability of success is 0.5. We're going to raise that to the power of r. So the power of r in this case is 1. So basically saying we make 1 success and all the rest are failures. So probability of a failure is 0.5. And if we're making 1 success and there's 4 trials, that must mean we've got 3 failures. So I'm literally just plugging numbers into this formula. That makes sense? Okay. Now have a look. What is 4C1? What is 4C1? It's just 4. Yeah, you can stick it in a calculator if you like. This is going to be 4. Okay? And then of course you've got times by a half and then times by a half to the power of 3. Does that make sense? Yeah? Okay. So then if we calculate this, it's not that hard to do in our head. It's just going to be 2 times by an eighth or a quarter. In fact, what am I going to do? Yeah, I'm just thinking about the best way. I'm going to write this actually as it is. So this comes out as a 16th. This is going to be 4/16. That's how I'm going to leave it. I'm not going to cancel that fraction down. Okay? So in other words, the probability of ending up in this bin is going to be 4/16. Does anybody see where that 4/16 comes from? There's 4 possible ways of getting to that bin. How many ways are there in total? How many possible? 16. There's 16 possible paths that you can take in total, and 4 of them will result in this bin. Hence, you get 4/16 here. Okay? But more importantly, have a look. Have a look at this. Okay? This feels very binomial. This thing down here, then, is just simply the number of possible paths. Okay? This thing here is the number of successes. This thing here is the number of failures. Okay, so in blue it's gone off a little bit. This is blue, this is the number of failures, in other words a left turn. This is the number of successes, the number of right turns. And this thing in black is just simply the number of different possible paths that you can take that will get you into each of those bins. Okay? The number of different possible paths that you can take to get to each bin is just this. It's the NCR bit. Yeah? Where n is the number of choices you've made, left or right, so the number of pegs effectively that you've gone through. Okay? The r is the number of times that you've turned right in each of these pegs. Does that make sense to everyone? So this kind of feels very binomial.